Okay, good morning. I welcome you all to Edge Area Online. So today we want to talk about integration. We want to talk about integration at grade 12, 11, and this is pure mathematics. So a topic called integration under pure mathematics in grade 12. So we can start by integration is the opposite of differentiation. It is the opposite of differentiation. Remember, there's a time we talked about differentiation, where we talked about dy over dx. So, but now when we're talking about integration, is the opposite of differentiation. Is the opposite of differentiation that we call integration. So, and we will be using dx. So we'll be using dx. So let's consider an integral of this manner. Let's say a x to the power n. Right? We are saying we are having a constant on this integral. There is a constant a, or a is a constant. A is a constant, and we call this indefinite integral because we are having a constant a. So what do we do with this indefinite integral? So this is the integral sign. So we say a x to the power n dx must be equal to a x to the power n plus 1 over n plus 1. So what does this mean? We are saying, remember, from differentiation we would subtract 1 first by multiplying with our power with the base number. But in this integration now, we are adding 1 to the power, and the resultant we divide by the resultant plus a constant c. So here now we are having constant a. Let's say this was a bx. So we're having a, b, and c as constants. So we're having a, b, and c as constant, and this n is not equals to 1. So this is how we complete the task of the integral part. So c is also our constant. So we're saying that when you are given to find dx, given an integral of the form a x to the power n, even if we have given b here, a b x, we would just add b there. So a b x to the power n dx is equals to a b x to the power n plus 1 over n plus 1, which is the result. So the step that we can follow when doing indefinite integral, or the steps that is followed. So what are the steps? So steps that you follow when you are completing an integral task, when you are integrating, we say add the power by 1. So we add the power by 1, that is adding plus 1. And remember, what we are referring to, the power is n in this case as an example. Then number 2, we now divide by the resultant, or the new power. So when we said n plus 1, we said over n plus 1, because that will be our resultant power, or our new power. So let's use a practical example. Let's say, what can we say? So the integral of 2x to the power 4 dx. So we want to find the integral of 2x to the power 4 dx. So how do we find this? So that means we are supposed to say 2x to the power 4 plus 1 over 4 plus 1 plus c, the constant that we want. And this gives us now 2x to the power 8, sorry, not 8, 2x to the power 5 over 5 plus c. That becomes our integral. 2x to the power 5 over 5. 5, where are we getting it? We are saying 4 plus 1, 4 plus 1. So 4 plus 1 is 5, which is that one. 4 plus 1 is 5, which is the other part. Another example that we can use, we can talk about 2. Let's talk about 2 over x to the power 3. So let's use 2, the integral of 2x to the power minus 3. Let's say 2 over x to the power 3 plus x squared dx. So we want to solve that integral. So what do? First, we consider dealing with this. So how do we do that? We can say the integral of 2 over, so we want this over to become, so we are saying according to the laws of logarithms or the laws of indices, we say 1 over x to the power 3 is equals to x to the power minus 3, right? So having said that, is equals to, so that means here we can now say this is now equals to 2x to the power minus 3 plus x squared. So what do we do next? So from this stage we can now say dx, don't forget dx, then we can now say 2x to the power minus 3 plus 1 over minus 3 plus 1 plus this one we can say x to the power 2 plus 1 over 2 plus 1 plus c. Don't forget to put the constant. So this becomes 2x to the power minus 3 plus 1, that's minus 2 over minus 2 plus x to the power 3 over 3 plus c, the constant. So we are having c as the constant. Then what do we do next? We can divide. So that means we can get x to the power minus 2, x to the power minus 2. This is minus because we are having a minus there, plus x to the power 3 over 3 plus c. Yes, and this can also be simplified as, so let's say 1 over minus x to the power 2. So this becomes, let me put the negative here, minus 1 over x squared. So we put 1 to remove the negative so that it becomes x squared plus x to the power 3 over 3 plus c become our new integral. Right. So this is another example. Let's move to another part of the integral which can be given as the form of, so the other part of the integration. So let's consider the integral of the form. We want the new form, so we're saying a plus b, ax plus b to the power n. Yes, we want to consider this nature, ax plus b to the power n. So how do we deal with this one? So we are having numbers like that. So what do? We can put the integral sign ax plus b to the power ax plus b to the power n like that, right, dx, which gives us now ax plus b to the power n plus 1 over n plus 1. But there is a condition where now our a, specifically this a is a coefficient of x. We multiply it here, right? When we now multiply, then we add the constant. So we are saying ax plus b to the power n plus 1 is always over n plus 1, but now we are multiplying with the constant a. So as always, a, b, and c are constant. They are constant. So if they are constant, we are saying a, b, and c are constant. But now this n is not greater than minus 1 under these circumstances. N now is no longer equal to 1. It's now not equal to minus 1 according to this one. So what do we do next? So let me look for example that we can use for our integration. Let me use another example. So the example that we can use, let's consider the integral of 2x plus 3 to the power 7 dx. So we are having this nature of the integral as an example. So what do we need to do? We can say 2x plus 3 to the power 7 plus 1 over 7 plus 1 plus a constant c. That gives us 2x plus 3 to the power 8 over 8 plus c. This becomes our result for the integral or for the integration. Let's now go to an example where now we can multiply by a the coefficient of x. So another example that we can use 1 over 4 plus 3x. 1 over 4 plus 3x like this dx. So this is a, this is b, this is a, and this is x. So what do we need to do with this? So first we can try to move this